Hi, everyone. My name is Paul Baker, engineering manager at Infotex. Uh, so the last PI, our team's been working really hard at adding in extra functionalities to support the bulk use case. So bulk enhancements. And what we're going to do now is just take you through the work that we've been doing so that you can so that you can see and appreciate what you've done and maybe even use it. So to start off with, I'm going to ask Paul Macon to talk about the why the bulk use case is so important, and he's going to sort of explain the use, why it's important, and also the bigger picture and how it fits into. Then I'm going to take you through what we've built, and we've got an announcement there. Following that, Vijay is going to give us a demo. It's a demo against a live merge loop switch, so I think that's pretty exciting. Then I'm going to get Sri to talk about the testing strategy that we put in place, and really the documents and support that we've got for that testing and where to find them. We've done a lot of work on that testing, so it's a good deliverable. Then Miguel's going to show us some patterns that we use in the architecture and why that is important. And then finally, I'll finish off with a roadmap on the features, what we've built and where we're going. Okay, so over to you, Paul Macon. Are you online?
Yes, I certainly am. I can see the slide as well.
Oh, fantastic.
Okay, great. So just to provide some context. First of all, I'd like to say people who've been to previous convenings and heard me talking about bulk will know this has been something that we've been talking about for quite some time now. I can't believe the massive amount of work that has gone into this by Paul and the team. They've really worked hard, and I think they're to be thanked and applauded for that. So thank you, Paul, and the rest of the team who are listening. Bulk is so important because it's about getting money into people's wallets, into people's accounts so that they can spend. So it's an enabling use case. So it's a core element of Pillar 2, helping deployments become more successful. From an operator's perspective, it provides a source of revenue as well. It supports the distribution of salaries, the social payments, the loan disbursements. In many cases, use bulk. So it's putting money into people's wallets that they can then use for other use cases. So it's a facilitator use case. Separately, in many deployments that we're looking at, there's a need to support social grant payments. In the past couple of years, there's been a focus on COVID support payments, but there's generally a need in many countries for support payments. And in Pakistan, for example, at the moment, we're seeing a need for flood support payments. So it's a really important use case. Can you go to the next slide, please? And it goes beyond the needs of just the operators as well. And here we see bringing in Pillar 3. This is about integration within the wider digital public good ecosystem. So, for example, I'm working with the G2P Connect team, and we're looking at integration with MOSIP, for example, and refreshing the integration with MeFOS. And there's the Open G2P DPG project, which is all about bulk payments. And of course, Open CRVS operates in support of MOSIP, essentially as an interconnected ecosystem in which Moduloop plays a key part. But in order to do that, we have to be able to do bulk payments. And by that, I'm talking payment lists of 10, 20, 30,000 people, and to do it in an efficient manner. And the work that Paul and his team have done actually enables this, and it couldn't be more timely because the G2P Connect team are talking about proof of concept within the next quarter. That may be ambitious, but it's certainly something that we are looking at. And I come back to the final point here: integration with MOSIP. It's becoming a strategic imperative, and it relates as well to the work that Michael and Koang were talking about yesterday in terms of international transactions. How do we build the oracles for these more complex pan ecosystem solutions? And Bulk is going to be a primary user of that. So I think that's all I wanted to say. Paul, it's over to you now to talk about what you actually did.
Yep. Thanks, Paul. Okay, so to describe what we built, I'll put this very basic high-level diagram together. So on the left, we've got the payer DFSP. On the right, we've got the payee DFSP. The bulk transfers goes from payer to payee. In the middle, we've got the merge loop switch. We've got the SDK scheme adapters enlarged on both sides, and that's because that's where our enhancements have gone. So what are we enabling with these enhancements? To explain that, I've got, before the beginning of the PI, the merge loop bulk functionality had a particular set of limitations. These were done by design, but the enhancements we're talking about are really to overcome some of those limitations. So what we've done is we've built or extended the SDK scheme adapter on the payee side so that we no longer have 1,000 transaction limit. Bulk discovery calls are now included as part of the bulk message, and the bulk message can go to multiple payee FSPs at the same time. We also support asynchronous mode, and that becomes really important when we're starting to talk about really large-scale bulk use cases. So on the payee side, we have designed to overcome those limitations, but they're still in the roadmap. We haven't tackled them yet. So the announcement is we've got this working in the Merge Loop 14.1 release, so it's available. And we've got a demo to show you. So, but before we jump to the demo, let me explain to you how you can use this functionality. So it's in the SDK scheme adapter, and that doesn't mean that you can't use it. There, in fact, are 3 different ways in which the SDK scheme adapter is currently used. The first way is we've got third-party support products, connection support products that have been built in the community, of which Payment Manager, open source Payment Manager is one of them, and it's the one I know most about, so I'm going to talk about it. So on the Payments Manager side, SDK scheme adapter is a component of that. So by upgrading and enhancing that component, you get those extra features and functionality as part of the Payment Manager. So in the second scenario that we got there is some people have just taken that SDK scheme adapter and they've used it directly in the integration. So they built a custom integration and connected it directly to their backend system. And this might actually be a chosen model if the FSP is in fact very focused on bulk, and there's lots of different integration points that are necessary. So that's an important one still. And then the last one is you don't use the SDK scheme adapter at all, but all of the work that we've done has been put in there and it's in open source. It's well documented. There's lots of references, so you guys should go and have a look if you're interested in the bulk use case. And effectively, you could use any of those pieces of documentation as a reference. So we're talking about interfaces, APIs, the event-driven patterns, some of the test cases, putting together complex test cases is important. And then the general business use case can also be used as a reference. Okay, so let's have a look at the functional design of what we built here. Here we've got a picture of a beneficiary management subsystem sitting on the payer FSP, and it's making calls through the SDK scheme adapter, which we've enhanced, which is then using the bulk functionality inside the merge loop switch. So we've split the bulk functions to align them with the 3 phases of the merge loop transfer, starting off with the discovery phase, then the agreement phase, and then the transfer phase. So when you initiate the bulk call, then for each of the sub transactions, we get a discovery call going out into the merge loop switch. The results are collated and then returned back to the beneficiary subsystem, which then confirms the party information that starts the agreement phase. We then batch those results in a way that Mojaloop can consume them. And then we send out those batches as a bulk quote message and collate the results. And then we do the same for transfers when the quotes are confirmed by the beneficiary subsystem. So next, let's start talking about the demo. So I want you to understand how, what we're doing when we display the demo. So to do that, we've got 3 FSPs here. We've got a blue bank, and we've got a purple bank and an orange bank. So the blue bank is the payer, and it's going to send 50 transfers, and 25 of them are going to go to purple bank, 25 to orange bank. To do that, we're going to use the TTK to trigger the message, run the use case. So it's going to be running a test case on the side, and then we're using TTK to monitor on the purple bank side and on the orange bank side so that we can see all the information coming through. And then finally, we're going to have a look at the financial portal, which gives us a central view of the transfers as they've gone through, and then we can see what's going on. Here's another view of it. We're going to, just to illustrate those API calls. So we start off with the TTK sending a bulk initiated API call, triggers the discovery phase. We get lots of get party calls going out, and the results are correlated and returned back to the beneficiary subsystem. And then we confirm the party information that triggers the agreement phase. We get 2 bulk calls going out, 1 to purple bank, 1 to orange bank. The results are collated, presented back to the beneficiary subsystem. And then finally, we've got this transfer phase which results in 2 bulk transfer calls, 1 to purple bank, 1 to orange bank. Okay, so now let's jump to the demo. So I've got a pre-recording of that demo because I was a little bit concerned about the
Hello everyone, this is Vijay
connection
Kumar.
here.
I'm going
Sorry,
to
let me
show
just-
you a demo of bulk transactions in the SDK scheme adapter. So this is the test setup. We got Mojaloop deployed along with 3 SDK scheme adapters, which are acting as DFSPs, blue bank, purple bank, and orange bank. So here blue bank is the sender FSP, and purple bank and orange bank are receiver FSP. So here we are using testing toolkit to simulate the core backend. So from the testing toolkit sender on the blue bank side, we are going to initiate the bulk transaction. And the testing toolkit on the purple bank and testing toolkit on the orange bank simulates the core backend and mock the responses. From the TTK sender here, we're going to execute a test case which contains the bulk transaction to the SDK scheme adapter. The transaction contains 50 transfers. So 25 transfers each to the purple bank and orange bank. The purple bank simulates 25 success and 1 failure out of those 25 transfers. And the same case with orange bank. It simulates 24 success and 1 failure. So at the end, blue bank should get 48 success and 2 failures. And we can see all these transfers in the finance portal. We also deployed the finance portal along with Mojaloop. And we can also see the position changes. Blue bank should be at 4,800 minus Tanzanian shillings because each transfer is 100 Tanzanian shillings. Let's see the demo. So before sending the bulk transaction, let's see the current position of the DFSPs. Blue bank is at 0. Orange bank and purple bank are also at 0. Let's execute the bulk transaction. So we have 3 testing toolkit interfaces. This is the blue bank. Here we are executing a test case on the Blue Bank, post bulk transaction, put bulk transaction, and another put. So first one is post bulk transaction. This request contains 50 transfers, 50 individual transfers. You can see the individual transfer array here. So there are 50 transfers. And the second request is to accept party. So accept party is true in all the transfers. And in the same way, the third request is for accept quote. You can see the accept quote is true. So we are executing this test case, post bulk transaction followed by 2 put bulk transactions for accept parties and accept quotes. We can see these individual transfers in the receiver FSP, that is Purple Bank and Orange Bank. So these are the testing toolkit interfaces of Purple Bank and Orange Bank. We can see the requests in this monitoring page. So let's execute this. Okay, all success. And we should get the inbound requests in the receiver side. You can see we got get parties, 25 get parties separately, and 1 bulk quotes. So this should contain 25 individual quote requests and 1 bulk transfer. We should also contain 25 individual transfer requests. And in the Orange Bank, you can see the get parties, bulk quotes, and bulk transfers. Let's see the response in the sender FSP. So we can see the response here. This is the response for first request, which is post bulk transaction. And here you can see the party information for all the individual transfers. And in the second request, we are accepting this party information, and we should get the quote information as callback. So this is the individual transfer results. There is ILP packet, pay receive amount, fee, and commission expiration. So this is the quote information. And in the third request callback, we should see the fulfillment. So you can see the fulfillment and the transfer state is committed. Let's see the position changes in the finance portal. I'm refreshing this page. The position of Blue Bank is at 4,800, and Orange Bank is at minus 2,400, and Purple Bank is at minus 2,400. Because 2 transfers are failed, we can see the transfers in the transfers UI. Here, Blue Bank to Orange Bank, 100 TJS. Blue Bank to Purple Bank, 100 TJS. The transfer state is committed here. So these are the individual transfers. Yeah, that is it. Thanks, everyone. Hello, everyone. This is Vijay Kumar. I'm going to show you a demo of bulk transactions in the SDK schema.
Oh. How do I stop that? Okay. Sorry. There we go. Relief. Okay. I hope you're all excited about that. I certainly was when I saw it. It's significant because, you know, this is through Mojaloop, and we now have an easy way to build integrations. So part of some of the documentation we've got in place is also how you can use this to integrate into your backend core system. So this is a huge enabler, and we can get the volumes up. Shri, are you online?
Yes, Paul, I'm here.
Brilliant. I would like Shri to talk about our testing strategy that we use, because nothing's really there until it's properly tested. So Shri, can you talk us through that?
Thanks, Paul. Hello, everyone. This is Shri from Infotex. For the past PI, I worked on the bulk features, especially defining the test strategy, implementing the integration tests and functional tests, and last but not the least, documentation of the test cases. So the slide that you're seeing on is the testing strategy taken. So mainly we have divided the tests into 3 categories: unit tests, integration tests, and functional tests. Unit tests are the ones that are written by the developers as they are writing the business logic. So in this call, I'm mainly going to talk about the integration tests and the functional tests. So integration tests, Paul, I think, can you please move on to the slide 18? I'm just going to reuse that slide.
Okay.
Yeah. So integration. No, sorry, the architecture diagram, the next one.
Okay.
The next one, please.
I don't know which.
Next one. Yeah, this one I would like to show. Thank you. So these tests are based on the flow of the sequence diagram, and these are implemented using the JEST framework. Because the command event handlers are the one that has the majority of the bulk process logic, all the narrow integration tests are written focusing on the command event handler. So which is sitting in the middle component, command event handler, I think 1. At a very high level, this command event handler consumes the command events and implements the business logic. The business logic is the part of the business logic is command handlers batch the request based on certain criteria and update the bulk transaction state in the Redis store that you see down, and then publish the appropriate domain events at the end of it. So that is the process involved in the command event handler. So when it comes to the integration tests, we have written the test to mimic the behavior of publishing the command event and then validating the state that is stored in the Redis, and then test the domain events that are published. Not just testing the domain events that are published, but also the data that is being published as part of these events. So that is all done as part of the integration tests. These tests are all part of the CI pipeline. You can go back to the main slide, Paul. The testing strategy one.
I'm trying.
Okay.
Here we go.
Thank you. So all these tests are part of the CI pipeline. So they ensure the regression for any changes that are being made to the code. That is how they are kept at the moment. These tests that you can find at a GitHub location. That is, the links to the specific GitHub locations are shared in the next next slide. That is about the integration tests and functional tests, which are also called the end-to-end tests here. The specific links are provided. So when I talk about the functional tests, that is testing the bulk transaction the moment when the payer triggers the bulk transaction request, and the response that the payer gets for the request sent, validating the response, how many requests that we have sent and how many responses we have got. Have we got all the responses for the parties calls? Have we got all the codes responses? Have we got all the transfers responses with the different statuses that we are expecting? And the bulk transaction status. Everything is verified in the end-to-end functional testing. So basically, these tests are triggered by sending a post-bulk transaction request from a payer FSP, and then final put callback response is validated. You can go to the previous one or stay in the same, yeah. So these are written in the TTK. Mainly these functional tests are divided into happy path tests and the negative tests. Happy path, as the name itself says, we are testing only the success criteria, a test that is going to be success, which is a happy path. And the negative test cases are all the error cases. So for even in the negative test cases, there are different categories for each of these calls for parties, codes, and transfers. So we named them as parties error cases, codes error cases, and transfers error cases. So the error scenarios are simulated using the TTK rules. Vijay has shown in the demo that we triggered the request on the TTK from the TTK UI on the payer side. So there are corresponding rules on the payee side to trigger these error cases. So that is how we were able to simulate those error cases. So they're all available at a specific GitHub location, which is shown on the next slide. So these tests are written in such a way that they can run both locally and also in the Mojaloop environment.
Great.
So
Thank you.
yeah.
Thanks, Sri. I think we're running out of time. I want to hand over to Miguel, but really good work on the testing, and we got some sort of testing matrices as well that show the extent of the functionality. So Miguel, can you talk about the architecture?
Thanks, Paul. So most of my job was actually done by Sri, because she actually explained most of the architecture very eloquently. So thank you very much, Sri. But I'll just give you an overview of why we chose this architecture. Well, we had an existing SDK scheme adapter. It was actually built to handle a lot of the synchronous kind of handling between Mojaloop, and basically hand off the asynchronous nature, and basically handle that complexity from an actual core banking system or FSB's perspective. And one of the things we wanted to introduce with this, since it's bulk, and we want to be able to process these things asynchronously, which obviously this might take a bit more time than usual. In essence, we had to introduce this asynchronous processing to the bulk SDK scheme adapter itself. But we wanted to also do this in a way that didn't impact the existing functionality and that existing synchronous capability that everyone loves about the bulk as well. So we basically introduced these changes in a way that interoperability or operate within the actual ecosystem within the SDK itself. I had a bit of a tongue problem there, words are hard. And we also wanted to do it in a way that also introduced or handles failures, as well as the scalability of the solution itself. And as a result of that, we introduced a lot of the patterns that were introduced as part of the existing core services, as well as what was introduced as part of the vNext architecture. In other words, we introduced patterns such as domain-driven design, the event-driven designs that we introduced. You heard a bit about the event handlers, the command handlers, etc. So those were basically adopted as part of the actual solution itself. And in essence, this means you can actually deploy the SDK in fairly flexible ways. You can deploy it as it is now, where it's just purely a synchronous interface and it handles a lot of the complexity of the Moduloop API perspective, and it basically hands off the asynchronous nature between the switch and the SDK. And you can also deploy it with the enhanced bulk functionality as well that Paul has just talked about. And also we introduced a couple of different infrastructure pieces. We already had Redis, but we introduced Kafka, and we wanted to do that basically as part of the handling the failure and the scalability of the product. We wanted to have that durability of the messaging capabilities of Kafka, specifically also with the way the asynchronous nature of the bulk messages are processed. And also it is Kubernetes ready. And this is something we saw in the version 14.10 update. There is now a Helm chart that's available, so anyone can actually deploy the SDK. Well, will be once the 14.10 has a final release. So this is the diagram that Shri already explained. I'll just give a bit more context. Can you see this pointer? No, I like pointing at things. So here's the backend API component and the FSP API component. These are existing components within the SDK scheme adapter. Those components have not changed in any major way, except for introducing the additional bulk transactions functionality. In essence, those components produce basically domain events. And we have these two components here, the domain event handler, the command event handler that was described by Shri for us, where we have the command event handler, which really handles the core logic, the rules, etc., as well as actually managing the state of the actual bulk itself. I think that's about it. I think that's right. Okay. Yeah. I'm not sure I understand you. Sorry.
No, just an important part that we got here, because we got
Oh, you mean the dependency injection?
yeah,
Oh,
the
sorry.
dependency injection.
Oh, sorry. And another pattern was about the dependency injection, right? So basically we adopted a way that in essence, we can change any of those backend dependencies, whether it's Redis or Kafka, we can easily change those since we have very much strict interfaces in terms of how we interact with those backends. So we can easily switch them out in future if that is a requirement.
Yeah. And that means that you can have sort of a massive GTP scaled deployment, or you can have a light one that just needs to do a few transfers together in a bulk message. So we can support both of those.
Great. All right, don't know what happened to the presentation.
Okay. Are you? There. So I would like to just thank the team involved in putting this together. There were lots of people, Kevin, Juan, Miguel, Sam, Shashi, Shri, Vijay, and Yevon, that all helped. So thank you guys. And this is a view of our roadmap. So I'm going to glance over this because I think we're over time. But effectively, what we've done in this roadmap, we've grouped it into three main sections. We've got the Moduloop Hub functionality on the left. In the middle, we got the DFSP support, which is the SDK functionality we've been working on. And on the right, we got our core standard core connectors there, which is really ways of interfacing into backend systems. And we're working on all three of them. High level, you can see that the light gray is what we had at the beginning of the PI. There's a lot more black. So we've added a lot of functionality. So good step in the right direction. But if you look below the line with the future roadmap features, you can see there's quite a lot more to be done as well. So if any of you out there are interested in this use case and want to help support the team and effort, please get in touch with me and because there's lots to do and it's very exciting. Okay.
Just also a quick thanks to the VNext team as well. We actually used a lot of their underlying libraries, specifically with the platform bounding context for logging, for messaging and all that kind of stuff. So that really was a huge accelerator for us. So thanks so much.
Yep, agreed.
Thank you, guys. I will defer questions. Please find them after if you have any. We're a little over time, but I want us to proceed to the next session, which is VNext.